everyone. In last lecture we have discussed about properties of hardened concrete. In today's lecture we are going to see about special concrete. Special concretes are the concrete prepared for special purposes like lightweight, high density, high performance, radiation shielding, etc. Concrete is a versatile material possessing good compressive strength, but it suffers from many drawbacks like low tensile strength, thermal attack, chemical attack, and then permeability to liquids, corrosion reinforcement, etc. Modifications have been made from time to time to overcome the deficiency in cement concrete. The recent developments in the material and construction technology have led to significant change resulting in performances and economical uses. Attempts are being made in the following ways. One is improvement in mechanical properties like compressive strength, tensile strength, and impact resistance, and another one is improvement in durability in terms of chemical and freezing resistance, and then improvement in thermal insulation, chemical attack, and then skid resistance, etc. The various types of special concretes are lightweight concrete, aerated concrete, no fines concrete, fiber reinforced concrete, ferrocement, geopolymer concrete, high strength concrete, high performance concrete, etc. Let's see one by one. The first one is lightweight concrete. The density of the conventional concrete in the range of 2200 to 2600 kg per meter cube. This heavy self-weight will make the structure uneconomical. The dead weight of the structural member made up of this concrete is large compared to the imposed load to be carried. A small reduction in the dead weight of the structural member like slab, beam, and column results in considerable saving in money and manpower. Attempts have been made in past to reduce the self-weight of the structure and to increase the efficiency of the concrete. The density of the lightweight concrete in the range of 300 to 1900 kg per meter cube. Let's see the advantages of lightweight aggregate. It reductions in the weight of the aggregate, and the smaller sections of the structural member can be adapted, and it increases in the progress of work, and it reduction in the foundation cost, especially weak soil, and it has the low thermal conductivity, and it offers more fire resistance. It has low modulus of elasticity and adequate ductility, may advantages in seismic design of structures. The use of lightweight concrete gives an outlet for industrial wastes like fly ash, clinker, etc. The lightweight aggregate can be achieved by three different ways. One is by replacing the normal mineral aggregate by cellular porous or lightweight aggregate, and the next one is by introducing the air bubbles in the mortar. We called it as aerated concrete, and another one is by omitting the sand fraction from the aggregate. We called it as no fines concrete. The aerated concrete is different from the air entrained concrete. The air entrained concrete contain much lower portion of air and in fact heavy concrete, whereas the amount of aerations is more in cellular concrete, but it is the lightweight. The aerated concrete may or may not contain the coarse aggregate. The densities of the aerated concrete between 300 to 1000 kg per meter cube. Lower density grade are used for insulation purposes, and medium density grade are used for the manufacturing of prefabricated structural members. Let's see the application of aerated concrete. It is used for load bearing walls by cellular concrete blocks, and it is used for precast composite walls or floor panels, and it is used for partition walls for residential, commercial, and industrial building. Let's see about no fines concrete. It is obtained by omission of fine aggregate fraction below 12 mm from the conventional concrete. It is the mixture of water, cement, and coarse aggregate only. Cement content is correspondingly varying. Very often, only single-sized aggregates passing through 20 mm and retained on 10 mm is used. By using single-sized aggregate, the actual void can be increased. The actual voids may vary between the 30 to 40% depending upon the degree of consolidation of aggregates. The strength of no fine aggregates is dependent upon the water cement ratio, aggregate cement ratio, and unit weight of concrete. When the conventional aggregate is used, the densities vary from 1600 to 2000 kg per meter cube. If we are using lightweight aggregate, the densities may be reduced up to 350 kg per meter cube. Though the strength of the fine aggregate is lower than the ordinary concrete, the strength are sufficient for using in structural member and load bearing walls in normal building up to 3 rise stories. Next we are going to see the high density concrete. It is also called as heavyweight concrete. It is obtained by the replacement of normal aggregate having specific gravity of 2.6 by aggregate having the specific gravity of 4. One of the most common natural heavyweight aggregate is barium sulfate. It has the specific gravity of 4.1. Other type of natural heavyweight aggregates are iron, hematite, magnetite, limonite and zeolite. If we are using iron or magnetite heavyweight aggregate, the densities may be obtained between the 3000 to 3900 kg per meter cube. The high density concrete can be used for the construction of radiation shielding structures like nuclear power plant structures, and it is used for preparation of counterbalance weight for lifting bridges and ballast blocks for ships. Fiber reinforced concrete is a composite material of concrete and discontinuous, discrete and uniformly dispersed fine fibers. The continuous meshes, woven fabrics and long wires or rod are not considered as fibers. The inclusion of fibers in concrete will lead to increases the ductility, flexural strength, impact resistance and fatigue strength, etc. Next we are going to see the ferrocement. Ferrocement is a new material consists of wire mesh and concrete. It consisting of closely spaced wire mesh and rich concrete mixes. The concrete mix provides mass and wire mesh provides the tensile strength and ductility of the structure. The ferrocement possesses high resistance against cracking, high fatigue resistance, higher impermeability and higher impact resistance. The construction of ferrocements can be divided into 4 methods. One is fabrication of skeleton frames and another one is fixing of bars and meshes and another one is application of mortar and another one is curing. Let's see the advantages of ferrocement. Ferrocement structures are thin and light. Due to this, sulfate of structure and ferrocement cost are reduced. The construction techniques is simple, does not require any skilled laborers and it is used for precast concrete elements. It is possible for partial and complete elimination of formwork. It is easy to repair of damaged ferrocement structures. Now let's see about high strength concrete. Based on the compressive strength, concrete is classified into normal strength concrete, high strength concrete and ultra strength concrete. Indian standard recommended methods of mixed design denotes the boundary at 35 MPa between the normal strength and high strength concrete. The high strength concrete is used for construction of the high-rise building and long span bridges. High strength concrete is achieved by necessary to use the highest cement content with the lowest possible of water cement ratio. It should be remembered that high cement content used in concrete which liberates the large amount of heat of hydrations which results in excessive shrinkage. The various methods to produce the high strength concretes are seeding, re-vibration, inhibiting cracks using admixtures, sulfur impregnations. Next we are going to see the high performance concrete. It is a concrete that has been designed to be durable and stronger if necessary than the conventional concrete. High performance concrete mixtures composed of same material as conventional concrete, but the proportions are designed or engineered to be durable and strong that needed for structural and environmental requirements of the project. The high performance concrete is achieved by low water to cementitious material ratio and the presence of cementitious material and chemical admixtures. Curing is considerably important and critical curing period runs from placement or finishing up to 2 or 3 days later. Next we are going to see the precast concrete. When mass concrete is required for huge and speedy constructions, the precast concrete is preferred. The precast concrete elements are manufactured at industries and transferred to the site. They are casted in separate forms and placed in the structure on site. Hollow and solid blocks of desired shape, sizes are casted in industries and cured at industry sites and transferred to the structure on site work. Let's come to the end of the video lecture series. In this series, we have discussed about composition, production and properties of cement, properties of aggregates and admixtures in concrete and concrete mix design and properties of fresh and hardened concrete and special concrete. I hope you all understand about the basic concepts of concrete technology. In future, we will see about more interesting topic in civil engineering. Thank you.